Welcome to TN Academy. Here we are doing question 4, where we have a map of the US, which different cities are connected, and we have the travel fares associated with them. Now, for our first question, the question asks, explain why the graph is connected but not complete. And the reason is that any city can be traveled to or from, but not all of the cities are direct. For example, Los Angeles and Dallas. Yes. And so an additional thing is that not all the routes are linear. Okay? So that's for question A. Let's just say, i.e., not all connected. Now, for our next question, we are asked to determine the shortest path here using Crusoe's algorithm. So to start this question, we first choose our lowest edge, which is here, CD, and we continue from there, choosing DN and LC, which was 49 here, and then Seattle to Los Angeles. And that would be the answer for our shortest route. Question B. Question B. Now for our next question, question C, we're supposed to use the edges that we found in part B and find our upper bound for our traveling salesman problem. Okay, so now we can't see the values here, but if we remember the trajectory, and here are those still visible. And then we take the MST, we take the sum of all these flights and double it. Okay? By the weight of our journey. The answer should come out to be 336. And with this, we can visit every area along this trajectory. Now for our next question, we are given some new information whereby Ronald lives in New York and he wants to fly to other cities before finally returning to New York. But after some research, he found that there's an existing flight from Los Angeles to Dallas costing $26. And for this question, we are asked to use the nearest neighbor algorithm, starting with Los Angeles, find a better upper bound than what we found previously in part C. And we have to clearly state all our vertices. So for question D, we are using the nearest neighbor algorithm, and we're starting from LA, going to Dallas, and then using the nearest neighbor algorithm, our next city would then be Chicago. Okay? And then following this, we would go to New York, then Seattle, and back to the beginning, LA. Okay? So if we saw that on the map, we are going from LA to Dallas, to Chicago to New York, and back again, using the nearest neighbor algorithm. And if we find the weight of all these trips, which include each flight, which are the prices of each flight, the sum of all the prices of each flight, plus 66 plus 58, our new sum should come out to be 248. And that's the answer to part D. And then for our next question, we're asked to remove the vertex that corresponds to Chicago, and then determine our new lower bound for our traveling salesman. So this is question E.I. And so with our new journey, the traveling salesman will go from LA to Dallas, and then Dallas to New York, and New York to Seattle. And then the journey will begin again, and the weight of our lower bound, is equal to, when we take the sum of all the flights, $123. Then for our following question, II, we are asked to do similarly, remove the vertex which represents Seattle, and determine our new lower bound. And so for the removing Seattle, our journey will go from LA to Dallas, Dallas to New York, and New York to Seattle. Dallas to Chicago, and Chicago to New York, apologies. Dallas to Chicago and Chicago to New York. And then when we calculate the weight of our lower bound, it will come out to be $219. Now, with all this in mind, we have our question F. With all of our previous answers, we write down the best inequality that Ronald, for the least expensive tour that Ronald could take. And we'll let variable C represent the cost. So we have C. We know the least expensive would be this bound here of $219. And the most expensive, with Donald's discovery of the flight from Los Angeles direct to Dallas, using the nearest neighbor algorithm, we found that it should cost about $248. For our final question, question G, we're asked to write down a tour that is strictly greater than your lower bound and within the interval that we've just created. Now for this, any tour is valid within the interval for any start point or any tour starting and finishing at N. For example, if we went from New York to Dallas to Chicago to LA to Seattle and back to New York, where the weight of this journey would be $234, which satisfies our interval. And that's all for this question.